Yesterday we looked at properties of parallelograms. They are shapes that have some nice symmetry to them, and therefore they ended up having some nice symmetrical answers as well. So for example, I've got a couple of parallelograms here, and if I look at these sides, they ended up being congruent to each other. If I looked at these sides, they ended up being congruent to each other, and I'll mark them separately. Or I could look at angles. This angle and its opposite angle are congruent to each other. Or we could also say then that these two are congruent to each other. We also looked at how the angles next to each other, for instance these two, or if I don't want to pick those two that are next to each other, these two, they would end up being supplementary. And today what we're going to do is start looking at, well, how can we prove that we have parallelograms? So we're going to be given a figure and we're going to decide if it really is a parallelogram. Today's will be based off of looking at a picture, and then next time, the lesson after that, will be if we're looking at some information and taking kind of an algebraic approach. But let's look at these pictures. Go to page 13 of your notes. Yesterday we looked at some parallelograms and we figured out information about their properties, and there are these nice symmetrical shapes, and so their properties ended up being nice symmetrical numbers. So for example, we had these two sides are opposite each other, and we realized, you know what, they're congruent to each other, just like these two sides would also be congruent to each other. But it wasn't just about sides, it could be about angles. This angle is opposite and congruent to this angle, or these two opposite angles will end up being congruent to each other. And one other property that we looked at was how, well, angles next to each other, or maybe we think about these angles being next to each other, they ended up being supplementary. Today we're going to be looking at proving that we have parallelograms. And there's two ways that we're going to approach this. One is going to be that we have a graph and we're deciding whether or not we have enough information to say we have a parallelogram. And another way, which will be the following day, we'll look at information and we'll decide if we have one based off of some algebraic equations. At any point in time, if you need to catch up with the notes or if you just need to find the right page, go ahead and make sure you hit pause. What you should do right now, though, is go to page 13 in your notes. We've got a bunch of pictures here, and we're going to decide if they're a parallelogram and explain why they are or why they aren't. For example, look at problem number 1. I like that I see opposite sides marked parallel. Yes, that's one of the properties of parallelograms, is opposite sides are parallel. So, yes, this is going to be a parallelogram because opposite sides are congruent. Because opposite sides are parallel. And I don't really feel like writing the word parallel, so I'm going to use the parallel symbol. Hopefully you can get yours to work out real nicely. Remember, they're real close parallel lines. I want to look at problem number 3. I look at this one and I say, oh, these opposite sides have congruent lengths. Well, that's also a property of parallelogram. So yes, this is a parallelogram because opposite sides are, did you come up with the word? I'm going to use the congruent symbol. So we've looked at one with parallel sides, we've looked at one with congruent sides. Now let's look at problem number 5, which is all about angles. And I look at this one, and it's got this property that we were just talking about. Opposite angles are congruent. Or were you thinking that adjacent angles, ones next to each other, are supplementary? Doesn't matter which one, they're both ones that would work out. I'm going to say, yes, this is a parallelogram, and my reasoning is because opposite angles are congruent. All right, what I want you to do right now is hit pause, and you decide whether 7, 8, and 9 are parallelograms, And if so, why or why not? Remember, we're really good at diagrams. We know we don't get to make assumptions. So what you're going to do right now is hit pause, then answer these 3 questions, and when you're done, hit play again to see if you got them right. How did you do? Are you surprised that none of them are yes? If you said yes to 8 and 9, you're actually on the right track, so I'm not disappointed by that at all. But I do hope that you can understand what it is that we're saying here. If you said yes to 8, I'm hoping that your reasoning was because we have angles that are supplementary. But I can't make any assumption about what this angle is and what this angle is. The rule isn't just that you need one pair of supplementary angles next to each other. They all need to be. So I would need to know a little bit more information. And the same idea happens in problem number 9, except for side stuff. Either I need to know that these sides are also parallel, or I need to know something about the lengths of these sides. So it's not just one set of opposite sides are parallel or one set of opposite sides are congruent. All sets are. All right, so those were kind of some trick questions. Really jumped right into those. Will you actually pick either 10, 11, or 12, hit pause, and then see if you got your answer right. How did you do on your question? All of these are yes. And you might be thinking, wait, I don't actually know, for instance, in number 10, what this angle is. Don't forget, it's a quadrilateral. You know it's 360 degrees. So it turns out that this angle has to be the remaining 70 degrees. So opposite angles are really congruent. I'm going to jump over to number 12. And we've got opposite angles congruent there as well for the same reason. Don't try to tell me that because I have right angles I have a parallelogram. That's not the rule of a parallelogram. It's just that opposite angles are congruent. So I want to look at number 11, whether you did that or not. Here we've got the diagonals, and the diagonals have been bisected. And remember, that was one of our properties of parallelograms, and we're going to use that on the next page. Go to problem number 15. In number 15, we're not trying to figure out anymore whether or not we have a parallelogram. We need to figure out what will make this be a parallelogram. And we were just talking about diagonals have to be congruent. So, diagonals have to be bisected. So I would need to know that 3x and 15 are going to be equal to each other. This section has to be the same length as this section. For the same rule, these being bisected, get kind of a cool color here, I know that 5 is going to have to equal 5y. So these are going to be 2 equations that I can set up and then solve for. What I want you to do right now is to finish number 15, try number 17, and then see if you got the answers right. How did you do? If you look at number 17, I've got opposite sides congruent in a parallelogram, and so the only way that I'm going to make this into a parallelogram is if the 2 sides are going to be equal to each other. So that's why I wrote this equation equals this equation, and then solve from there. And then the same thing happened for the blue one. If you feel like you're doing pretty well at these, what I want you to do is to work on your assignment from your worksheet or from your assignment guide. And if you're doing well with those, if you don't have too many questions, just go ahead and continue on with those problems. If you are having a difficult time, make sure that you're talking to other people in the class, but I will also show a couple more examples on here if you want to come back to them. So what you might want to do right now is pause this and then realize, oh, I'm doing super well, I don't need to go back to it, or maybe you're struggling and then you're going to continue watching the rest of this because I'll do a couple more examples from this page. All right, good luck on your assignment. If you're listening, that means that you've come back for some additional information, and good for you for doing that. I want to look at problem number 16, and normally I'd love to know that I've got these 2 diagonals, and so I know one is going to be congruent to the other. But that doesn't help me solve for x and y in this problem. So I'm kind of forced in this problem to use the idea that adjacent angles are supplementary. So I'm going to end up figuring out that y is 95 degrees, 180 minus 105. All right, well now let me use the idea that opposites are congruent. That is nice. So I know now that 15x is also 95, and when I solve that, I'm going to get x is 6. I also want to look at problem number 18, where we now have diagonals. And I do know the property that diagonals are bisected. So what that means is this top section here is the same length as this bottom section here. Well, I've kind of covered some stuff up. So what we're saying that we know is 2y is equal to 24. So I can solve for y. And then the same would be true for that other diagonal, this one. I would know that 6x is going to be 72. When I divide both sides by 6, I find out that x is 12. And let's look at one more, problem number 20. We're back to angles here, and I like the idea of using that opposite angles are congruent because those angles both have the same variable in them. So I'm going to set these equal to each other, and I'm going to do some work on there. I'm also going to set these equal to each other, and I'll do some work on there. And why don't you try to do the problems, but hit pause first, and when you replay it, see if you got the right answers. How did you do? If you're doing well, fantastic. See if you can get some of the problems out of the book done. If you're still struggling, that's okay. Just make sure that you ask some questions. It could be to someone else in the class, in the ARC. You know what you need to do. Good luck.